Imagine this. You are standing on a long empty road. You take a step forward. Then another. Then another. But suddenly, someone asks you, "How far did you go?" You answer, 10 meters. And they respond, "Okay. But in which direction?" And right there, your answer becomes incomplete. Because in physics, movement is not just about how far. It is also about where. And that is where vector quantities come in. Part 1: The foundation of physics. In physics, everything we measure is called a quantity. But not all quantities are the same. Some are simple. Others are more descriptive. We divide them into two main categories: scalar quantities and vector quantities. A scalar quantity only has magnitude. Magnitude simply means size or amount. Examples include distance, speed, time, mass, temperature. These are straightforward. They only answer one question: how much? But vectors go further. A vector quantity has both magnitude and direction. It answers two questions: how much and where. Part 2: Understanding with real life. Let's imagine a simple situation. You walk from your house. If you say, "I walked 5 meters," that is not enough information. But if you say, "I walked 5 meters to the east," now the information is complete. Because direction changes everything. Two people can walk the same distance, but end up in completely different places. That is the power of vectors. Part 3: Why direction changes everything. Direction is not just a small detail. It can completely change results. Imagine two forces acting on an object. One pushes to the right. The other pushes to the left. If they are equal, they cancel out. The object does not move, even though forces are present. Without direction, you would think something should happen. But with vectors, you understand why nothing happens. Part 4: Common vector quantities. There are several important vector quantities in physics: displacement, velocity, acceleration, force, momentum. Let's understand them one by one. Displacement is the change in position with direction. Velocity is speed with direction. Acceleration is how velocity changes over time. Force is a push or pull in a specific direction. Momentum is mass in motion with direction. Each of these depends on direction. Remove direction, and they lose their true meaning. Part 5: How vectors are represented. Vectors are usually drawn as arrows. The arrow has two important parts: length and direction. The length shows magnitude. The direction shows where it is pointing. A longer arrow means a stronger value. A shorter arrow means a smaller value. This simple representation helps us visualize motion and forces. Part 6 Vector Addition. Now we move to something very important. Vector addition. Imagine this. You walk 3 meters east. Then 4 meters north. Where are you now? Not 7 meters in a straight line. Instead, you are somewhere diagonally. To find the result, we draw a triangle. One vector goes east. Another goes north. The result is the diagonal. This is called the resultant vector. It shows your true displacement. Part 7 Real-world applications. Vectors are everywhere. Pilots use vectors to control direction and speed. Engineers use vectors to calculate forces in buildings. Game developers use vectors for character movement. Space scientists use vectors to control rockets. Even your phone uses vectors in GPS navigation. Without vectors, modern technology would not exist. Part 8 Vectors in daily life. Even if you don't notice, you use vectors every day. When you drive a car. When you throw a ball. When wind pushes objects. When you follow directions on a map. All of these involve vectors. Physics is not just theory. It is reality. Part 9 Scalars versus vectors. Let's make the difference crystal clear. Scalar. Only magnitude. Vector. Magnitude and direction. Distance is scalar. Displacement is vector. Speed is scalar. Velocity is vector. This difference is one of the most important in physics. Part 10 Final understanding. At first, vectors may seem complex. But they are actually simple. They just add one thing. Direction. And that one thing changes everything. Outro, powerful ending. So next time you measure something, ask yourself, is it just a number? Or does direction matter? Because in physics, direction is the difference between confusion and complete understanding. Ending CTA. If you enjoyed this deep explanation, subscribe for more powerful science content. And keep exploring. Because science is everywhere.